Some persons are actually missing. Was not seeing the Chanel or and Deborah. So and I haven't actually I haven't started to record the class. So they miss all of this.
Sir,
Mm.
what is the point of the
Uh, you're chipping out there.
sir, I was saying that if you record from Zoom, is it saved or not saved? Because I see recording from
Is it,
Zoom, sir, not on YouTube. I'm talking
oh, you
from
seen
Zoom.
it recording there now? Oh, okay. Look like oh yeah, well look like me set it for record automatically. So then get to it. The thing about it is if it record on Zoom now, for you to get it, I going to have to go find it and then edit it and so on. And I really don't have a time for editing a video. So the main reason I use YouTube is just that, I don't have any editing to do after.
Yes, sir.
Um so I can't really guarantee say if it record on Zoom as you're seeing it there now that that we can edit it. Because yeah. I have to convert it then and possibly shrink it now to a size way, you know.
So, sir, it takes
Mm.
up a lot of space to record.
Yeah, because HD recording
Oh,
it recording a HD and like for a class now, my videos are as big as like sometime I when I think the last class was like 1 gig. Um like 1 gig sometime I'll be 600 megabyte. So if I'm doing it 2 times a week and I'm doing it for 3 subjects, it, it's crazy. Um, I have a 4 terabyte hard drive and it's half full. Most of it is Zoom videos. So
four
that's
terabytes,
why.
sir. Mine is at 1 terabyte, sir. So you probably full already.
Well, there you go. Um, so that's how it is. But um, so I use YouTube. That's the main reason. It's just easier. I mean, the video not come out as I want it most times, but at least you guys can skip through and find the parts where relevant to you. Um, all right, let's put this in there. All right, and all right, so there you go. Send the SOS there, and this thing seems to be recording. All right, good. All right, guys. So this is again, this is just a little run through um the turning forces, moment of a force. Again, I have to go take it seriously. The definition, them my main thing. The formula, you know, there's no formula for center of gravity, but there's a definition. And then it is also related to the moment of a force. Hooke's law has a definition which you'll need to know. I was telling some students yesterday, and that was well in a face-to-face class. It was like Hooke's law there. For deformation is Hooke's law. You're also gonna need to know what is meant by elastic limit. That's within Hooke's law, and then there's also the spring constant. So these are terms related to deformation that CXE send the broad topic, but you're going to basically break it down to keywords, and those keywords that every topic break down into, you're going to know them, and they will be asked or used to ask questions in the exam. All right, so can't say. I mean, when you watch these videos after the exam, you're going to say, "Well, sir, they tell you." I just want to cover my back. I don't know if you're going to cover yours. That you're the ones who going to have an answer to your parents. The good thing is that they know that classes are being held and that, well, for the most part, they know that you are here. Um, and probably they even hear some of the things that I'm saying. And then, so when the exam come now and they ask you, how was it and so on, well, you guys, I'll be smiling because I'll say, yes, I know I did my part. Did you do your part? That's what you're going to have to answer to. But I'm giving you tips every day. At least every class to give you some tips. And these are the new tips, are the modified tips here. Break down every one of these topics into simpler topics and know every single definition and keyword that is used in these topics. I could add also to the turning forces, you have the principal moments, which we realize that is for any moment question, the principal moments is very major. It's like very important to know. So let's put principal of moments here. And so all these really add up together. All right. So any questions here, guys?
None, sir.
No, sir.
All right. So remember now, we are in the stage right now of our preparation where we are trying to finish covering the topics that they will send. That's the first stage. Next stage now is to focus only on past papers and do a whole heap of different activities to bring out the thing. Whether you're going to use the maybe just a test or something in the classroom, we can use Kahoot. We can use any platform where to build the energy and the vibes to practice and revise. So, but we have to cover the material first. It don't make sense to do even one Kahoot and ask a question and then everybody getting the answer wrong. We have to make sure it's everybody there on the same page and going through the topics them individually. Of course, these ones now spending time on are the ones that we didn't do from September. All right, the ones now 11 and 12, 13 and 14, these are what we want to look at right now in just a little nutshell type of thing. So we spoke about alternating current last class. Anybody remember anything about alternating current?
So both ways, sir. And direct current, you talk about direct, sir.
Yeah. But what is hold on. So what is alternating current?
They have the ability to change direction, sir.
Ability
Elections,
to
the
change
flow.
direction. Oh, okay, go
Like
no
the
man.
flow
Fix
of
it up. Fix it up. 2 marks the question of the value. What is meant by alternating current?
electric charge.
Sir,
Uh, yeah.
if Sunday remember, I think you say if AC voltage, the voltage reverse polarity, periodical
Uh-huh.
reverse polarity. That means they change direction of flow, or
Okay.
cause current to flow in a reverse direction.
Sir,
Yeah.
please, sir. Yes, sir. I did say it can flow both ways, sir.
Can flow both ways, but then I want a definition, something that you would have tell CXC, you know. But all right, so for 2 marks, you get a mark for mentioning the direction. And you sort of have the idea there between January and Benito. There, the idea is there, but how will it be written on the exam? So current that periodically reverses its direction of flow in a system. Could I add that? So in a system. Simple enough, but they get this. But they understand what this is saying.
Yes, sir.
Yes, sir.
I
Yeah,
could say electron flow, sir.
we could, but we want to avoid using the electrons when it is not specifically asked about. If they ask about current, they stick to the current here. That's the simplest definition. You wouldn't be wrong though, January, that was, but then you want to give the simplest definition. Think about it. It's like if you had like a little brother or sister and they ask you something complicated, you wouldn't use the words, your words. You'd have to try use for them words. So think of CXC as that. I can tell you the simpler you can explain something is the better you explain it. Because it would mean that, it would mean that whatever complicated definition you have in your book, you would know what it means to make it simple. That's the thing. Bear in mind, the definition I'm teaching you, most of them I didn't learn it that way. But as time goes on, it got simpler. When I just leave college, it was, I gave my definition, it was right out of the book, everything word for word, right? I read through the book one time, the book in my head, I say, all right, bam, that's right, the definition can tell you, say, all right, according to this book, Stephen Pope or whichever book, Oxford or whichever one, they're right, the definition, what them say. But then we realize, say, but then does everybody understand that definition? One of the main things that change the way I teach students to define things is teaching at different schools. So right now I've started at probably say 6 or probably 7 different schools. Teach a school where I have very fast students. That's where I started out at St. Hilda's, and very, very sharp set of girls that got I stayed there for 3 set of students really. Carry them up to CXC. And they were just, and so I could just give them the definition right out of the book. Some of them even know it before me even write it. They do them exam, they get good grades. Say, all right, bam, start teach at other schools, go across, Eustatius, even spend time at was at even St. Jago one time. And even at Knox and so on. Everybody learn different. Spend like 3 years at Theatius Golden, and then now I'm at Belfield for the last 6 years. So I mean, that's how it has been. So at the end of the day, use the words that you understand to define anything. All right. If you are using words that you don't understand to define something, it's either you're going to swat it or you're going to forget it. One out of the two. And I don't want you to put your brain on no stress to swat anything. Use words that you know to define. Right? So if you say AC current, because they could even ask you to define current by itself. But then if they ask you to define AC current, you will get the full marks for saying that it's current that reverses its direction of flow periodically. This is a safe definition for 2 marks. All right. Other books will say something more sophisticated. But at the end of the day, it is correct. Whether it was simple or whether it was sophisticated, same 2 marks. All right. It's better you understand it than you're swatting it and not even sure what you're writing. Because right now, I can go through this definition and teach you some whole heap of something where it's in the definition, but you don't see it. I could circle current. We could define current. And we could also define what periodically means. So what if you were asked to define current? Anybody knows how to define current?
So the flow of
Flow of
electric charge in a
electrical
circuit.
charge in a material.
All right, so the Genarian and Benito very sharp on that one. Their flow of charges. You say electrical charges, all right. Flow of charges, all right. Current is the flow of charge, all right. Is the flow of charge. All right.
Material would be more correct, sir, because it does have to be a circuit, right, sir?
Yeah. Well, that's
Could
why I
be
don't put
wires
anything
and
after that.
stuff.
That's why I don't put anything. I don't put anything after current is the flow of charge because it could be in a material, it could be in a conductor. I mean, yeah, in a material you could write that if you want to, probably nail it in deeper. In a material, or I could put in a substance, doesn't matter. But current is the flow of charge. All right, so that's current. Alternating current. Current, that type of current that reverses its direction of flow in a system. Question is, why does this current reduce or rather reverses its flow? All right. So question now, why does alternating current reverse its flow? If you can answer this question, then you answer something here. Why does AC current?
Sir, sir, it would be like a phone to sir, like those new phones, sir. Like I don't know if they consist of it, sir. Like those new phones that can charge back and forth, sir, of each other.
I don't know what phone you're talking about, Janari, but I am concerned about why does AC current reverse its direction of flow? That's the question I want to answer right now. All right. All right. So let's go back to our knowledge of current. We're saying current is the flow of charge. What causes the flow of charge?
What causes the flow of charge?
Yeah, what causes charge of flow? First of all, but right now at this moment, there are charges flowing inside your body.
Yes, sir. That would I put we now one of the parts, sir, like atoms and electrons and whatever.
Yeah, but we're not go there, so. Current is flow of charge and there's current in your body right now. If suddenly those charges in your body stop moving, what's gonna happen to you?
Body stop moving, sir.
Well, yeah. But but then when you go to the
Probably would die
hospital,
too, sir.
hold on,
Probably would die too. Don't know.
probably depends.
Because if the heart, probably everything will stop heart and everything, sir. So
Well, all right, hold on. Where is the current in your body? The current that's in your body right now, where is it? Where it's coming from?
Your brain.
Yeah. Good answer. That's it. What's the purpose of the brain?
send signals, sir. I don't know.
Pretty much send signals everywhere in the body. And what is it using to send those signals?
I don't remember.
You don't remember. But
But
why
sir,
not?
I saw nerve system, sir, or some kind of something.
All right. Hold on to that, Janari. Anybody else? How the brain communicate with the rest of your body?
A nervous system, so like pathways. So.
All right. You said nerves. Yeah. You just said nerves. And Janari was mentioning nerves. Nerves is the one answer, one keyword here. Nerves. So nerves, they have a brain, and the brain is connected to these nerves. And as you said, there's a pathway. So yeah, just like how there's wires from the light post into your house. Those are pathways. That is how your body is wired. So your body is wired from the brain, all right, to every single part of your body through nerves, right? That's why you have what them call a nervous system. I hope everybody is aware of that. We have a nervous system that actually it works using electric current. The nerves use current. The nerves actually have charges that them send from one nerve cell to the other.
Just always see things, animated things, sir. Like when they open that and go in your brain, sir, you see look animated thing. You can see it has send something, sir. Charges.
Right. So that's where it is, guys. All right. So there's current in your body now. It's a flow of charge. Those charges pretty much from the food where you eat. So that's why you need to eat. If you stop
So
eating,
they say the nerves, if you remove all nerves or something in your body, sir, you can wrap around the earth 2 times or something like that.
yeah, that's a bit extra trivia, but yeah, that's possibly true. All right, guys. So the question is, if there's current in your body, where come from? I say the brain, but there's something though that current needs though. The current doesn't flow naturally. All right, it has to be forced actually to flow. And
It's something like a stimulus.
a stimulus. Okay, using big words there. Stimulus. Who is that? That sounds like Shantai. Very good. Stimulus. I like that. I like that. And there's a word that starts with V that means stimulus.
The voltage.
Yeah. And I wanted to make it clear that it wasn't a biological word, so it was coming out of that. The voltage was actually it's a stimulant. Actually, voltage is a stimulant for current. So voltage is where the current come from. All right. So our voltage is what produces current. That's a better statement. So therefore, current is caused by voltage. So that's where the word voltage come into play, guys.
I
It
usually
is-
heard everybody usually say like current is voltage, sir. Like, like when people don't really understand,
Yeah.
sir, but they usually say current is voltage.
Right, but there are two
But
different
them-
things. Right, as you're learning now, there are two different things. So voltage is actually there's the electrical force which causes current. All right, so electrical force that causes current. Or
They
current to
have
flow.
resistance to, sir.
Well, yeah, we don't quite reach here yet. All right, so that is where voltage comes from. So so AC voltage produces AC current. All right, AC voltage produces AC current. But then we keep on asking why, what causes the AC voltage? Where does this AC voltage come from? All right. So, all right, AC voltage actually from all right in generators. So this is where the term comes in now, guys. This is why it's important for us to know about magnetism and generators. CXE made it clear on the list of topics that they will ask about. See it here. If you look at topic 11, they are asking about alternating current, but topic 13 is about magnetic forces and electromagnetic force at 14, motors at 15. Motor, get this in your head from now. A motor is the opposite of the generator. So whatever a generator does, the motor does the opposite of it. And last class I told you what a generator does. So using that, you should be able to figure out what a motor does. But all right, so you see all of these things that I put like a asterisk beside as important stuff to know. All right, AC voltage is the source of AC current that reverses the direction of flow. All right. As we say, AC voltage is produced from magnetism in generators. All right. Now we'll need to know what is in a generator that causes this voltage. No, but we said I spoke to you about magnets the last class, and then I said, or you guys should recall though, that
Yes, sir.
a magnet is made up of two parts.
North and South Pole, something like that, if you remember right.
Yeah,
About repel and attract, sir.
very good. So, and I hope everybody else was there. Amari, you were there?
Yes, sir.
All right. And I'm seeing doing. All right. Let's see what's going on in this waiting room. Seeing like a lot of activity here. All right. Let's see everybody. All right. So, all right. As we say, guys, focusing on keywords here. The magnet has a north and south pole. But then and as I say, as we dive in deep into that matter here with the magnets here. We have a North Pole and we have a South Pole. There's something that is
Attract, sir.
well, yeah, but before I come to that, why is it called a North Pole and why is it called a South Pole? All right, what's the difference between a North Pole and a South Pole?
They're opposites, so like
Opposites?
yes.
Okay. Opposites, yeah. All right. Opposite, something opposite there. Well, yes, all right. You mentioned, I think January said something about attraction. What was it? If you say attraction and opposite, I like that. You're on the right track
Opposite
there.
attract, sir. Like just like electron, sir. Opposite
Right.
attract.
But we want to focus on this part though, which is simply what makes a North Pole a North Pole. Why is it called a North Pole? All right. Now, one thing you should remember now, or to seek to know there, North Pole is usually assigned as a positive charge, something that's as positive, whereas the South Pole is usually assigned as a negative, sort of a negatively charged pole.
Like
So
what I
that's
said, sir, about electrons and atoms and something.
right. So there is, as you say, that attraction now, they could ask you to, because them say a magnetism there. One I think you need to understand too is that there is the North Pole is always seeking after the South Pole. So because of that, there are forces, magnetic forces, which leave from the North Pole and seek or go towards the South Pole. So they really terminate there. All right. So, and the reason why it's called the North Pole is that magnets tend to align themselves where, well, first of all, the Earth is a magnet. So North Pole will, in a magnet, will align itself with the poles of the Earth. So, in other words, wherever the magnet points, that direction, wherever, because let's look at something. Everybody know what a compass look like?
Sir, that brings us back to the point where before you were talking about clouds, sir, like the bottom of the clouds supposed to have negative charge. And
No, a difference from that. Difference from that. We're not going to so. We're talking that is sort of what you call it?
I was comparing it to a magnet, sir. Like the top of a magnet is north, sir. I was comparing to that, sir. If you understand what I mean.
Yeah, but the top of the magnet is not the north.
I'm positive, sir. I was talking like that, sir. Like a cloud, top of the higher clouds is positively charged, sir.
Yeah, but I don't want you to relate the two of them because it's different concept and it might confuse others. So I don't want to go there. Just focus on the issue here. The issue is that the North Pole is usually it's positively charged. South Pole is negatively charged. There's a reason for that. But the compass was the question I asked about. Everybody know what a compass look like? Ever see a compass before?
Yes, sir.
If you look at a compass, guys, this is what it looks like. So some persons don't know. And
it works off magnetism, sir. I learn about compasses.
All right. You notice that in the compass, this is where you used to find your direction when you're lost. So you know, in the forest or wherever you don't have any signs and you're somewhere you want to find, especially when you know where you're supposed to go. But this red part, you see this red part here, right? Yes, color red so that you always know where north is. The North Pole is usually red or given a red color. All right. As a thing in physics and electrical to some extent, red is usually positive and of course negative is usually black. Let me, I don't know. They have the red and black system of wires. So if you're looking at wires, the red wire is usually the positive wire. Usually there are different codes, but in the old days it was red. They used to use red and black wire. So yes, that's why you could
neutral, sir.
Yeah. So they want
a black I should say for the neutral and red for the positive. What you just said, sir.
All right. Anyway, so guys, I would say this is the magnet there. All right. I would say, guys, magnets point they work because of the Earth the earth has iron in it, and then iron is actually a magnet. So it's able to tell us where the North Pole is. Where is the source of the magnetism from the earth? And that's why the magnet points there. It points to the source of the magnetism. So that is how it come about. However, what happens is that if I put in a piece of wire between the north and the south pole of a magnet, all right, some guy tried this and he discovered that there was something happening in those wires. He realized that the magnetic force could actually move electrons in some materials. All right, so magnetism can cause current to flow. And what happens now is if I move that material from the North Pole to the South Pole, it's going to experience a different type of force. And because the forces are opposite to each other, notice that the for the North Pole, it goes away, but for the South Pole, it comes in. This is why they attract. So while the North Pole is pushing, the South Pole is pulling. All right, guys. That's what causes the attraction. One, the South Pole is pulling, North Pole is pushing. A pull and a push complement each other. Any questions here?
No, sir.
All right. So popular CXC questions from this could ask you to show the magnetic field. And this is the term magnetic field, because a magnetic field is where that force of magnetism is really felt. And so that's what causes the current to flow now. So in materials now, in some materials, not all, magnetism, and when you use this word, induces or causes current to flow. All right. Example in metals. Copper. Yeah, definitely copper would be one. So, all right. So I'm leaving you with this, guys. The principle here behind the voltage, behind AC current, is the north and the south pole of the magnet, right? And the fact that you introduce a wire or any metal between the two poles, and current is induced in it. All right. And because that material is exposed to both the north and the south pole, then it will experience a different force, which causes the direction of flow to change. All right. So like if we were to plot a graph, and CXC asks a lot about this, if we were to plot a graph here, all right, it would look like this. Let's just put this in black so that we make this neutral. All right. All right, black. Yeah, here it is. All right. So then, like, if we're to put a graph of usually it's voltage against time. All right, let's put voltage. The voltage produced, and they will show this. There's a device used to measure this called an oscilloscope. It's like that thing in the hospital where they pin on you to see if you know to measure your heart rate. So
I know it's
yeah. So they know that if you get a flat line, you know, so you're gone. But how it works though, guys, if you plot the voltage on a graph for this, it will look like this. So it will be, remember, say if you learn in the maths, you know, this part are positive. And if it's a T graph, them usually use here. So the top part is positive, and then of course the bottom part is negative. So what happens with AC current is this. Half of the current is positive. The other half of the current is negative. So that is because this is where it faces the South Pole. And of course, the positive.
I remember you teaching us that earlier, way back earlier, sir.
Yeah.
And waves or something.
Sing just this goes off on me so. Right. No. Yeah. All right. Let's repeat that. All right, guys. So. All right. All right. When this come back, guys. So. Anyway. I think there's a little problem here. So guys, all right. So we end it there. I think the Prime Minister run out of space and then the thing does crash. Yeah.